The Miyano BNA-42GTY is the first generation of a Miyano sliding head gang turret machine. It features a total of 10 cutting axes, X1 through C2. The benefits of this model are that it is built on a space-saving design. As you can see, the machine has a very small footprint. It weighs approximately 8,250 pounds. The bed has been constructed like a platform to maintain flat surfaces and reduce deformation and distortion to minimize the effects of heat. The spindle and tool slide are mounted on this smooth and uniform surface, so even in the event of thermal expansion, the displacement is all in the same direction, which means that relative dislocation between the workpiece and the cutting tool can be controlled. The high rigidity spindle is a key component as it adopts angular contact ball bearings at the front and double row cylindrical bearings at the rear. Rotating accuracy is assured by the angular contact ball bearing, while the radial loads are supported by the double row of cylindrical roller bearings. Here we see the layout of the 10 axis on the GTY machine. On the left side we have the Z1 sliding head main spindle with full C axis. Located also on the left side is a gang slide X1, Y1. This slide has 3 turning stations and 3 live tools and cross-working positions for the front work. A drilling block with 5 sleeve holder positions is attached to the same X1, Y1 slide that can be used for back work. The main turret has 8 positions for both fixed and live tooling. In addition, the turret has half index capability for additional tools. With an X2, Y2 and Z2 axis on this turret, we have a much greater range of multi-head tools that can be utilized. The sub-spindle with full C axis and X and Z motion allows us to machine on both spindles at the same time with the main turret. The third tool from the gang plate can also be used in conjunction with the turret tools. Here we see the tooling area on the BNA-42GTY machine. The small work envelope helps in reducing cycle times. The layout of X1 and Y1 of the gang plate are shown here, along with the X2 and Y2 on the turret. Note that the optional 7-position back ID block is shown on the left. Added benefits on the GTY are tool indexing time is shortened by adopting gang tools, cutting with up to 3 tools simultaneously with 3 axis control groups. The next higher class of spindle motor is adopted. This has the highest output of the BNA series. Calculation speed is increased with the NC controller, the Mitsubishi M730VS. Machine performance is maximized with the Cincom control, and the machine is compact in size despite having 3 axis control groups. Features of the NC controller are the ease of overlapping operations due to the M730 control, the high-speed processing of builder macro functions that shorten cycle times, It has a compact operating panel with an integrated display. Continuing with features of the NC controller, we have improved machine and data features. Sub-spindle positioning is performed automatically for part pickoff. It performs automatic setting of work coordinates, automatic G50. The turret can move to a safe position by a T-code command, and simplified programming by using special G and M codes. Low frequency vibration is now available on the GTY series for the X1 and Z1 axis. What is low frequency vibration? In general terms, low frequency vibration cutting is where a servo-controlled axis generates vibration behavior in an axial direction. Machining is then carried out while synchronizing this vibration with spindle rotation. This creates air cutting time during machining and leads to intermittent chip disposal. The diagram below shows two cutting paths through two revolutions of the main spindle. The light blue area is showing the cutting area of the first revolution. The darker blue area shows the cutting area during the second revolution. This video graphic shows the cutting paths as described in the previous slide. Oscillation that is synchronized with the rotation of the spindle. It is also phased with spindle rotation. Here we are seeing the oscillation during cutting, which breaks the chip. This leaves a corrugated surface. The high spots are removed on the second rotation of the spindle. The air cut breaks the chip. When the axis reaches the programmed endpoint, the oscillation stops and a flat surface is formed. For more information on LFV, please contact your local distributor. Here we see some of the time-saving features within the control. Tool calls can be made along with axis positioning. Direct Z-axis command. Go from turning to a milling process with a simple GO-C0 command. No need to send Z-axis to reference home. Smooth threading cycles, shortcut positioning. The lower right image is showing a toolpath with shortened movement, all saving cycle time.
Hey Tim, I got a question here.
Yeah.
What is the lead time for the GTY machine purchased with LFV?
The lead time would be between 5 and 6 months after the order is placed.
Thank you.
Yep. Here's a list of the GTY's general machine specifications for your review. Main spindle 6,000 RPM, sub and live tooling 5,000 RPM. Standard machining length on the Z1 axis is based on the Z1 axis stroke. The main spindle chucking has a DIN 173E system as standard. The unit accepts B42 and TF48 style collets. The main spindle draw tube is 43 millimeters in diameter. And the machine comes with 4 spindle liners or filler tubes of various sizes for the main spindle. The length of the main spindle is approximately 33 inches from the collet face to the rear of the spindle. Sub-spindle accepts the same collet as the main, however the draw tube ID is 30 millimeters in diameter. Here's a list of sizes of the 4 spindle liners included with the machine. The machine comes with either a hinge type chip conveyor or a 250 micron filter type conveyor. The gang tool layout has 3 turning stations that accept 3/4 inch shank tools. The 3 rotary spindles on the gang accept ER16 collets, but the turning and rotary tools are for use on the main spindle side. Attached to the same gang plate, we have a back tool block with 5 sleeve locations that are 1 inch in diameter. Here we see the layout of the gang tools viewed from the sub-spindle. The optional 7-position back ID block is shown at the bottom left side. 3 live spindles for crosswork are located in the same area. Above that, we can see the 3 gang turning stations. The turret is on the right side. As mentioned earlier, the turret has 8 stations plus half index. The addition of the Y-axis gives us more tool and flexibility that greatly enhances the amount of tools that can be used on both main and sub spindles. Cooling through tooling can be utilized on each of the 8 stations and has a pressure of around 135 psi. The image on the left showing the turret with multi-position tool holders. The image on the right shows the turret live tool drive mechanism. The tools are driven via tang drive. Double, triple, quad holders show us sufficient tool positions, even for complex workpieces. Various Y-axis fixed and multiple live tool heads are available. We have here a quad cross drilling holder, 2 live for the front side and 2 live for the back side. The turret will accept tooling from all other BNA series models. Standard tooling package comes with a variety of OD and ID tooling. The triple plane head holder utilizes the half index feature on the machine.
Hey Tim, we have a question here. What is the size drill sleeve holders? What size drill sleeve holders does the optional 7-position rear tool post use? 3/4 or 1?
On the option, I believe they are 3/4 inch, but I would probably have to confirm that at a later date.
I'll tell you, they're all 1 inch. 1 inch.
1 inch. Okay. Thank you, Brian. CNC includes a more powerful Mitsubishi M730VS that comes standard with a multitude of CNC features that were not available on previous generations of the control. In addition to the functions on the right, support software has been added to reduce cycle time and setup time. Machine and support screens, such as the machine and data screen and toolset screen, make setups easier and quicker. Here we see the improved machine and data page. Various items are entered, including the position point or clearance point value, location of the cutoff tool in the turret. This allows for an automatic cutoff similar to a Cincom Swiss machine. As mentioned earlier, sub-spindle positioning is performed automatically for part pickoff. Here we see the machine and data page that asks how far the part needs to be sticking out of the sub-spindle. The sub-spindle moves to the correct location without the need of giving a coordinate in the program. If a stopper is to be used, it is entered in the machine and data file. When the start position key is activated, the machine will automatically index to the stopper position. Operator-friendly user screens make setups easier. Select the function and press the start key. No need to type in an activation code.
Tim, we got a question. Is there any thought of creating a back work block to utilize high pressure coolant through tools?
I know of one customer in the New England area that requested this many years ago, and I believed we came up with a solution. I don't believe it's in the quotation, but I'm sure that there was a manifold for high pressure made for that back tool block.
Thank you.
Yeah. Reliable program checking with on-machine program check function. Run through the program using the hand wheel. It's safe, it's easy, it's user-friendly. Program screens that improve operating convenience. The program screen is organized for easy reading. It can be displayed in synchronization with the editing screen. This simplifies the editing of complex programs with a lot of queuing. The code list screen. This displays the list of G and M codes, including descriptions of the arguments to assist in programming. This makes it possible to check the basics about the codes without referring to an instruction manual. When editing the program, you can insert codes just by inputting an argument. We can see on the right side an explanation of a G114 code. For complex sequences of operations, such as superimposition machining, machining patterns are optimized for particular purposes and are registered as G codes. Cycle times can be shortened by making use of these G codes. They also enable efficient programming and shorten the operator setup time. Various options for simultaneous machining are available due to the unique layout of the axis and innovative tooling blocks. We can independently simultaneously machine with two tools. On the left side, we are turning the front with the turret and turning the back with the gang tool block. On the right side, we are milling the front with the turret and drilling the back with the gang. Continuing with independent simultaneous machining with two tools. On the left side, we are turning the front with the gang and turning the back with the turret. On the right side, we are milling the front with the gang tools and milling the back with the turret. Superimposition, simultaneous machining of front and back. On the left side, we are turning the front and back with the turret. The X3 and Z3 on the subspindle are superimposed with the X2 and Z2 motion of the turret. On the right side, we are drilling the front and back with the turret. The Z3 on the subspindle is superimposed with the Z2 motion of the turret. Superimposition, simultaneous machining with two tools at the main spindle. On the left side, we are turning with two tools, rough turn, finish turn, or pinch rough turning. The Z2 on the turret is superimposed with the Z1 on the main spindle. On the right side, we are cross drilling with both the gang and the turret live tools. Superimposition and simultaneous machining with three tools. On the left side, we are pinch turning on the main spindle, rough turn, finish turn, or pinch rough turning. The Z2 turret slide is superimposed with the Z1 on the main spindle. At the same time, we are turning the back on the subspindle. The X3 and Z3 are superimposed with the X2 and Z2 on the turret. On the right side, we are turning with the gang tools while drilling with the turret on the main spindle and the subspindle. Setting the tool blocks on the turret of the BNA-GTY involves selecting a tool holder for each turret position. Here we see a double plane head being selected. The geometry for the ID locations are recalled by the machine when the holder is selected. There is no need for X tool data. The offsets to be used for the locations are then defined by the operator. The holder that is selected is saved with the program. The offsets are registered to each tool holder. Here we have a double turning block that is assigned three offsets: T1111, T1141, and T1121. If we call up a T1151 in the program, an alarm will occur as the offset is not registered with this tool holder. Here's a short video of the GTY in action. Turning with the gang tools on the main spindle while drilling the front side and the back side with the turret. Then grooving the front while boring the front and back with the turret. Cross drilling the front with the turret while machining the ID on the back with the gang ID tools. Rigid tapping is standard on all spindles. pinch milling on the front side with the gang and turret live tools. Having two opposing y-axis allows for greater flexibility in machining. Milling the front and back with the turret with a double-ended live tool. Finally, we pick off and cut off. Special G codes simplify all of these features. This was a project. It was for an AR-15 sight bases, back sight and a front sight. These parts were previously done on a machining center using extruded aluminum that had to be pre-cut. It was then fixtured on a mill, and it took 5 to 6 secondary operations using different fixtures. The total cycle time on the mills was about 3 minutes. So that's cycle time. That's the cutting of the extruded bar stock. That's the fixturing, loading, unloading. On top of that, 3 minutes. So the parts, we ran them using 1-inch diameter aluminum round bar stock on the GTY with a 12-foot carb 42 bar feeder. Parts were machined complete on the GTY in about 3 minutes. The GTY was selected because of the pinch milling capability and the ability to run unattended. Here's a short video of the front sight being machined on the GTY. The front end is faced, then turned with the gang tools. Then the turret is used to groove a relief for the milling. Now we're pinch milling on the front side. This reduces cycle time and stabilizes the cutting process. The milling continues on the front side while the back side machining begins. We are contour milling on the subspindle side. Live face drilling on the sub side. Drilling on the sub side. And finally, rigid tapping on the sub side. The square profile collet was used to pick off the part using synchronized spindle and phasing. And gentlemen, that concludes our presentation for today. I'd like to thank you all for attending. If you have any further questions, please type. Thank you.
Tim, do you remember how many tools were in that job?
In total, I believe on the turret alone there was probably about 10 different tools, plus 3 in the gang, 13, turning tool 14.
Just looked like a lot. Looked good.
A lot of tools. Yeah, it was a very interesting project. Yeah, but say part complete, one setup. You know, that's the way to do it. 12-foot bars.